Alright, students. So today we're actually going to talk about fronts. Alright, and as we indicated in class earlier, a front is in fact that boundary where you have two different or two distinct air masses, where two distinct air masses meet. Alright, now students, when both air masses meet, referring to specifically warm and cold air masses, at that junction where those air masses meet, that is what you call a front. There are, in fact, four general types of fronts. We call them warm fronts, cold fronts, stationary fronts, as well as occluded fronts. All right, students. So let us begin with cold fronts first. All right. Bear in mind that cold fronts actually are, in fact, associated with seasonal changes. All right. Primarily, when it is in the month of December, January, it is in fact winter in the northern hemisphere. I'm going to use the northern hemisphere for example, right? And the cold, unsaturated, dry winter air from the northern hemisphere would actually push down and advance towards the tropics. All right, so this whole big Caribbean region and the tropics over, right, especially in the northern hemisphere, would in fact be experiencing this phenomenon where the cold winter air from the northern hemisphere advances and pushes down towards the tropics. All right, so remember that for me. So the cold air interacts with the existing warm tropical air of the tropics, specifically referring to the northern hemisphere, that is above the equator. All right. So this particular image basically highlights this cold bunch of air masses, which are in fact advancing, and technically what it does, it pushes against the existing warm tropical air. All right. Now, warm air already rises. Keep that in mind. All right, because they have a lot more thermal energy. Cold air descends, but this, apart from descending, this cold air is also advancing. It is moving towards a specific environment. All right. During the course of the, like say the end of December, there are in fact several days, especially in the Caribbean here, there are in fact several days which would be very, very cold. All right. And these days are in fact relatively cold because of the fact that the cold air from the north, the winter air, the polar air, is in fact pushing down towards the Caribbean. All right, which is the northern part of the tropics. Now, the fact of the matter is that this phenomenon is responsible for the temperature to be subjected to decline. All right, and when it declines, all right, we must bear in mind that this is because of the cold air being unsaturated, has limited amount of moisture, limited amount of thermal energy. Okay, at this particular junction, however, when there is in fact the presence of the cold mixing with the warm, at the exact junction, there can also be the significance of cloud cover, all right, which can also be associated with a mild rainfall. All right. Now, this symbol, right, which is in fact associated with the cold front, is in fact it's kind of tooth-like formation, all right, and the actual pointed characteristic here would in fact be facing the direction to which the cool air is in fact advancing towards. For example, this cold front is essentially advancing towards the southeastern part of any given area. All right, because as you can see, it points towards the southeastern region. All right. This on top of the beyond that, as you can see from this image here, the cooler side of the air is on this side. Why? Because this shows the advance of cold air sweeping towards an existingly warm area. All right, so keep that in mind for me, please. Now, with respect to warm fronts, right? This is in fact the symbol associated with warm fronts technically. The actual directional movement of this particular warm front, this kind of semicircle will be facing the direction it is moving towards. So technically, the arrow also give us an indication also where the warm front is in fact advancing towards. Now, warm fronts, bear in mind for me, warm fronts always move from an existingly warm environment where you have general warm air or warm areas, and these warm air masses will actually move from the high concentration area, which is here, towards an area which is colder or cooler. Hence the reason why the warmer air would be within this region here, advancing towards a cooler environment. All right. Now, the presence of a warm front, all right, once you have the convergence of warm and cool air interacting, it will result in significant changes in weather. But warm fronts predominantly can be associated with the significance of kind of thunderstorm conditions. Why? Because warm air is said to be associated with saturated air, moisture rich or moisture laden air. And this interaction will be associated with great updrafts and rising warm air masses, all right, as it still come into contact with the existing cool environment. Okay, and warm fronts as such can bring about such changes to the point where you have a lot of rainfall. You may also have distinctive low atmospheric pressure. At the same time, you will also be associated with instability in the atmosphere, dense cloud cover, and stuff like that. Now, looking at the Earth, right? Since the tropics is in fact associated with warm air, dominance of warm air, we must bear in mind that the warm fronts really originate from the tropics and move further northwards or essentially southwards. All right. We pay more attention to the north primarily because of the fact that wind systems are in fact much more distinctive northwards. Right. For example, above the equator, air mass is technically traveling in a northwesterly direction. All right. So what we know fully well, this warm air from the tropics, this dominance of warm air, actually follows a directional pathway towards the temperate areas, right, which can actually exist between 30 to 60 degrees north and stuff like that. And these warm air masses can technically result in that mixing of the warm air with the existing cold air. So if we are in the tropics, we don't experience warm fronts. Why? Because we are already existingly warm. But areas which in fact experience warm fronts are in fact out of the tropics, referring to mainly temperate areas, either between 30 to 60 degrees north on average, or even 30 to 60 degrees south. All right. And even further towards the direction of the poles as well. All right. Keep that in mind for me, please. All right, this image actually shows the advancing warm air, right? When I say advancing, this means that the warm air, in fact, moving in a particular directional pathway and trying to engage the existing cool air on this other side. This warm air, since it is in fact advancing, it will be forced to rise, all right? And as it rises, it eventually results in significant cloud development and condensation and stuff like that, which is in fact associated with frontal uplift. Why do you call it frontal uplift? Because you have two different air masses relating. That is exactly what a front is. Since we have the advancing warm air, this is technically referring to the warm front sweeping in to any given area. All right, so this is here is what we're talking about, a stationary front. Now, stationary fronts are in fact associated with almost similar momentum of two distinct air masses referring to either warm and cold air masses, all right, moving head on towards each other where they actually converge. All right. And this momentum is considered to be somewhat similar on both sides of the spectrum. As you can see, this is a symbol which is associated with a stationary front. All right. The cold front in this particular diagram, the cold front is in fact moving easterly, whereas the warm front is in fact moving westerly. All right. Stationary fronts. The reason why it is said to be stationary fronts is because of the fact that it is essentially remaining in a kind of in somewhat of a stationary position or in the same position. All right. It is not dramatically moving from this one area to the next. All right. It sort of lingers. All right. Now, from this image, we could actually see the wind. This is in fact a stationary front in the middle here, all right, where both air masses are in sync. And what happens here is that the air itself, the wind patterns are in fact moving parallel to the front. And the parallel movement of these wind patterns, all right, in relation to the front itself would be responsible for creating that stationary effect. The weather conditions associated with this type of phenomenon would actually be, yes, you will have significant cloud cover. You would also have the presence of rainfall. All right, and yes, cloud cover will be significantly dense as well. All right. If these air masses are in fact very distinctive, for example, you have distinctive cooled as well as distinctive warm air currents, what happens is that the interaction would result in a low atmospheric pressure. All right, in a lower atmospheric pressure, which would contribute to the instability of the atmosphere. All right. Now, an occluded front is in fact associated with both the cold fronts as well as the warm front, kind of uniting with each other, where both of them are in fact moving in the same directional pathway. For example, look at this little area above. You can actually see the occluded front where you have the warm semicircular shape together with the symbol for the cool front, both of them moving in the same directional path. Now, what happens is that this is created when you have advancing cool air, right, moving very quickly towards an existing warm band of air currents, all right, to a warm front. And as they kind of merge together, all right, they both of them would technically fuse to create a symbolic system, which would actually move in a particular pathway as well. Both of them would actually be fused together to move in a specific direction. All right. Okay, let's keep that in mind for me. Now, put that in perspective and look at this for 1 minute, right? This is in fact the cooled advancing air masses, right, which symbolizes the cool front. And this warm air tend to linger, right, for a certain extent. As you can see, the cool air contributes to high winds. Now, cool air basically are referring to unsaturated air masses, and bear in mind that winds always blow from a high pressure to a low pressure. So the cold air will symbolize high atmospheric pressure where the winds are in fact coming from. So cold air contributes to high winds, and basically the existing warm air, you can see fully well the cold air move in a specific pathway, and this existing warm body of air would actually be met by this advancing cold air. All right, so the whole system is in fact moving in a specific directional path. The warm front, as you can see at the bottom here, the warm front provides steady rainfall. Why is that? Because warm air masses are in fact very saturated. And the presence of this cool air mixing with this warm air, even if they are moving in a singular pathway, in a specific direction, both of them are moving in a specific direction, all right, they will sweep rainfall across the land, all right, as both of them move in a specific line, all right, to a specific area from point A to point B in a unidirectional path, all right, as we would have highlighted here, where the cold air is in fact advancing upon an existing body of warm air. All right. Remember, warm air will actually be subjected to vertical ascent. So it basically does not necessarily move laterally, but more vertically. All right. However, the cold air, which is sweeping in, will come into contact with that existing body of warm air, which will technically push the system in a specific pathway where both of them will in fact move in a specific direction. All right, and this too would also be associated with significant rainfall and dense cloud cover, and also by extension low atmospheric pressure and stuff like that. Okay, so I hope this was actually helpful. All right, just to reiterate very quickly, here are in fact different types of fronts. We have warm fronts, cold fronts, stationary front, as well as occluded fronts. All right, the actual symbol, the shape of this particular symbol will point the direction to which the fronts are in fact moving. For example, from the screen here, this warm front is moving northwards. This cold front is moving southwards. This stationary front, the word stationary means that they are in fact remaining in the same position. So that means that they will in fact linger in the same spot. All right, and also we have occluded fronts. Both the cold and the warm fronts would actually fuse together. Both of them will be in fact be moving in a specific unidirectional path. All right. So I hope this was actually beneficial. Feel free to ask any questions. All right, students, you go keep good. Bye.